In this example, we are asked to determine if the following vector field in R3 is conservative. So let's begin by recalling that if we have a vector field defined by components f, g, h in R3, we know that it is conservative when the partial derivative of f with respect to y is equal to the partial derivative of g with respect to x, if the partial derivative of f with respect to z is equal to the partial derivative of h with respect to x, and if the partial derivative of g with respect to z is equal to the partial derivative of h with respect to y. So we're going to need to confirm that this vector field is or is not conservative. We need to find these partial derivatives and then check for their equivalences. So thinking about the vector field that is given to us here, you know it's in R3, so it has components f, g, h. So we'll save a little space here. We can say here is f, here is g, here is h. So starting with component f, we have 2xy minus z squared, and we need to find the partial derivative of f with respect to y, as well as the partial derivative of f with respect to z. So the partial derivative of f with respect to y simply leaves us with 2x. The partial derivative of f with respect to z is minus 2z. So we have our g component here is x squared plus 2z. So we have we want to go ahead and find the partial derivative of g with respect to x and the partial derivative of g with respect to z. So the partial derivative of g with respect to x is 2x. Partial derivative of g with respect to z is 2. And last but not least, we have our h component, which is defined as 2y minus 2xz. And so here we need to find the partial derivative of h with respect to x and the partial derivative of h with respect to y. So the partial derivative of h with respect to x is going to leave us with a minus 2z, and the partial derivative of h with respect to y leaves us with 2. And so we're ready to check to see if this vector field is conservative. So our first check, we want to know, is the partial derivative of f with respect to y, is this equal to the partial derivative of g with respect to x? And we could see, yes, they are. 2x is certainly equal to 2x. Next, we want to determine, is the partial derivative of f with respect to z, is this equal to the partial derivative of h with respect to x? And so looking at our partial derivatives, we have minus 2z is equal to minus 2z. Woohoo! And one more to go. We have the partial derivative of g with respect to z. We want to know, is this equal to the partial derivative of h with respect to y? And looking at our list, we can see, yes, 2 is equal to 2. And so we are able to confirm that therefore f is a conservative vector field. Woohoo! And so this is our beautiful final answer.